Okay, engineers, in this video we are going to cover a glitch on the method. Glitch means that the method has some failures, some possibility is not going to work. Okay, so I'm going to start with an example, an example showing why it fails, the method. Okay, so let's propose the particular solution. So it is exponential of 3x, so it's a very simple proposal. So the particular solution should be a exponential of 3x. So now we have to calculate the first derivative to plug in here. So it's going to be 3a exponential of 3x, and the second derivative is going to be 9a exponential of 3x. Okay, so it should not be very long problem. So let's replace in the differential equation. 9a exponential of 3x minus 2 first derivative 3a exponential of 3x, and then minus 3 here, the proposed solution, a exponential of 3x, and that should be equal to the exponential of 3x. Okay, remember that we have just plug in the solution in the differential equation. So this is the particular solution, second derivative, this is the particular solution, first derivative, and this is the particular solution according to this differential equation. Now let's see what happens here. So we can factorize the exponential of 3x, so it's going to be 9a minus 6a from here, and then minus 3a exponential of 3x equal to the exponential of 3x. Okay, now this number here is where the problem comes from. The addition of this is 0a exponential of 3x equal to the exponential of 3x. Now the method says that we have to make this coefficient equal to this coefficient, and this coefficient happens to be just 1. So 0a is equal to 1. Now, is that possible? Well, the answer is no. 0 times anything, here is a multiplication, 0 times anything is equal to 0, so it's impossible to get equal to 1. In other words, a is equal to 1 over 0, and that doesn't exist. So the method crashed. So here we have a crash on the method. Okay, now why it crashed, that's the question. Why this solution is not the correct solution? Okay, the answer to that is because we forgot to calculate the homogeneous solution. The homogeneous solution is actually this one, the characteristic equation. We forgot to make the homogeneous solution, and it is going to be m squared minus 2m minus 3 equals 0. The coefficients, the roots is two numbers in which the multiplication is minus 3 and the addition is minus 2 plus 1. Okay, so my first root is equal to 3 and my second root is equal to minus 1. So the homogeneous solution, or the first and the second solution, is c1 exponential of 3x plus c2 exponential of minus x. So here is why the method crashed, because the particular solution is a exponential of 3x, this particular solution. Now check the homogeneous solution, it is exactly here. So what happens here is that my particular solution is included, or is within, or it is already in the homogeneous solution. So the particular solution is within the homogeneous solution. So that is why we have 0 here. That is why we get 0, because this is supposed to be the solution of the homogeneous differential equation, which is equal to 0. So that is why we get 0 here. So what should we do to fix this problem? Okay, the fix is very similar to the repeated roots case. Okay, because the particular solution is repeated in the homogeneous solution, to make it linear independent, what we did in the previous videos is to make it linear independent, so let me write it here. The particular solution is linear dependent on the homogeneous solution. The particular solution is included in the homogeneous solution. To make it linear independent, in the repeated roots cases, the second solution was just x times the first solution. And actually that is the fixed engineers. The particular solution in reality, the particular solution must be a x exponential of 3x. Now, this is the linear independent proposed solution from the homogeneous. So what you have to do here, engineers, that is why I usually calculate first the homogeneous solution to see if my particular solution is not included in the homogeneous solution, to see if the particular solution is linear independent from the homogeneous. If my particular solution is independent, then I proceed with the solution. But if it's not, then I multiply as many x as necessary to make it linear independent. So this particular solution is not in the homogeneous. Okay, so let me erase this part and let's solve the particular solution using that. Okay, so let me do this. Because I will need space, so my particular solution is going to be a x exponential of 3x. And now let's follow the procedure, the same procedure as usual. We just calculate the derivatives and replace in the differential equation. But here you have to be careful because you have a multiplication here. So the particular solution derivative is going to be x exponential of 3x times 3 plus exponential of 3x. Derivative of x is just 1. Okay? So we have a multiplication there. So the particular solution is going to be a 3x plus 1 exponential of 3x. We factorize the exponential of 3x, alright? So that is the first derivative. Now the second derivative, again we have multiplication. So the particular solution second derivative is going to be a, and here is going to be this times derivative of this, 3x plus 1 exponential of 3x times 3, and then plus exponential of 3x, derivative of this, 3. So the second derivative is going to be, let's factorize what we can factorize, 3x, 3 times this 3, 9x, and this 1 times 3 is 3, plus 3, plus 6, exponential of 3x, okay? Now let's replace in the differential equation. So I'm going to use already this. So this is the second derivative, so it is here the second derivative, and then minus 2, the first derivative, minus 2a, minus 2a times 3x plus 1 exponential of 3x, and then minus 3. I'm going to erase this part. I need this space. So minus 3. Minus 3, the proposed particular solution, ax exponential of 3x, and now that should be equal to the exponential of 3x. Okay, so let's factorize what we can factorize. So it's going to be a from the right, 9x here, and then 2 times 3 minus 6x, alright, and then minus 3x from there, alright, and then plus 6 from here, and then minus 2 from here, and that's it. Exponential of 3x. We factorize the a to the on the left and the exponential on the right. Okay, just let me check the numbers. 9x minus 6x, 6 and minus 2. And sorry, I forgot this minus 3x. Okay, it's here. Okay, and this should be equal to the exponential of 3x. Okay, let's reduce this. A times, now what happens here is that this cancels. So the only thing left here is 6 minus 2, 4 exponential of 3x equal to the exponential of 3x. So now we can do this coefficient equal to this coefficient. So 4a must be equal to 1, so a is equal to 1/4. Now that we have found the particular solution, then the coefficient, sorry, the particular solution, then it is going to be the value of a 1/4 x exponential of 3x. Okay? Okay, so the homogeneous solution, the general solution is the homogeneous plus the particular. The homogeneous is here, c1 exponential of 3x plus c2 exponential minus x plus the particular 1/4 x exponential of 3x. And that's it. Okay, now, common question. Because we propose the particular solution to be x exponential of 3x, shall we include the full polynomial? The particular solution 8x plus b exponential of 3x. No, because what we are doing here is making different. The initial particular solution was exponential of 3x, sorry, a exponential of 3x, but we realize that this is actually here. So we have to multiply times an x, which is this. But don't get confused with the full polynomial, because if you do this, the b is going to have a problem, because it's going to be ax exponential of 3x plus b exponential of 3x. And again, you have this is included here. So there is no need to write this. You just keep with this one, which is here. So your proposed particular solution, just multiply as many x as necessary, and don't get confused with the full polynomial. It's a common mistake in the students. Alright? Okay, see you on the next video, which is, I think we have pretty much covered the undetermined coefficients. Next video, next subject, we are going to see what to do when it is not exponential, not sine or cosine, or not polynomial. What if we happen to have a natural logarithm? So we are going to see another method. That's by the way, it's a very long demonstration.